Hi everyone, thank you so much for joining. I'm Siddharth, I'm a community manager at Aviyel. Aviyel is on a mission to help open source projects sustain by creating communities around them and by incentivizing the contributors. This is another session of the Contributor Roadmap series. Contributor Roadmaps, if you do not know, is a step-by-step approach towards open source contributions with interactive sessions and mentorship. If you're someone looking to gain exposure as an early adopter and contributor, do check out the roadmaps. The link will be dropped by someone in the team shortly. In this session, we have Suhail. Suhail is a software engineer at SOTI. He'll be introducing us to the programming language Rust and telling us about all the hype that's around the programming language and why does so much hype exist. He'll also be demonstrating on how you could use the Rust client of Typesense because that's where we're heading at, and this is part of the roadmap for Typesense. Thank you so much for joining us, Suhail. Over to you.
Okay, thank you, Siddharth. So yeah, okay. So hi guys. So my name is Suhail, as Siddharth introduced. So I'm a software developer at SOTI. So yeah, so I'm mostly interested in low-level system programming language like development, Linux development, and yeah, mostly into security and all those stuff. Yeah. So nothing much. Yeah. So I'll just go forward and start. So yeah, so what's for the agenda? So mainly I'll just go through the introduction and some basic REST constructs, and we'll stop with a demo using Typesense. Like it won't be a big demo. Like we only have some APIs already implemented in the Typesense client, so we'll be showing some use cases. So yeah, so let's start with REST. So maybe I'll stop my screen. Sorry, the camera. So it might take some bandwidth. Sorry. Okay, yeah. So let's continue. So as an introduction, what is Rust? So Rust is a systems programming language. So it was like developed in 2011 or something by a researcher from Mozilla. So it was like initially developed as a hobby project, and after that it became mainstream. So it's a low-level programming language which is mostly typed, unlike like our Python or other languages, which are like far easier to use. Yeah, so it is typed similar to C or C++, and it is another one of the main advantages of Rust, like which makes it like apart from C and C++ is like its memory safety. So our usual issue which we have with C or C++ is that they have pretty low level and they are fast and everything, but they have many security issues and like memory safety bugs, race conditions, double free bugs and all. So like the main advantage which Rust gives is like it's this memory safety guarantee and like fearless concurrency, so that we can create multi-threaded applications without any fear of like having any race conditions or any other bugs. So another thing is like it is very efficient. Like recently there was one survey which like Rust comes as second most efficient programming language in terms of like its power usage and all those stuff, and how fast it is. And regarding memory also it's pretty good. Yeah. So also performance wise also, yeah, it's pretty fast. Like it doesn't have any garbage collection, unlike like languages like Java, which uses the feature like garbage collection for preventing any memory bugs or like keeping track of the memory. So Rust doesn't have any garbage collection, and everything happens at compilation time itself. Like every memory check and like everything happens at the compilation time, and yeah, so no runtime overhead. And so it also has pretty good tool chain. Like so if we take into consideration of JavaScript or Node environment, we have npm, right, for package management and uh, all other stuff. So similarly like Rust has one package manager called Cargo, which is also a tool chain which we can use for many handling many stuff when developing Rust. So for adding the modules and like all running and debugging, yeah, many stuff. So it comes with the language itself. So unlike language like C or C++, where if we need to handle this, yeah, build and like publishing the library or executable, which are mostly manual and like it's pretty hard. So with Rust and this Cargo, it's pretty simple and straightforward. Yeah, so I'll be showing some examples in the it will be coming up. Yeah, so we can go to the next slide. So yeah, so some of the basic use cases, like yeah, obviously, so backend development, like web server development and other stuff. So since it's pretty fast, like similar to Java and all, and doesn't have any memory overhead, so they are a good option for backend development, since they provide good concurrency and like type safety and memory safety features. So it's pretty good, and it's also really good for developing CLI applications, like command line tools, for like similar to what we have in our Bash or like in a terminal, right? So with good interface, yeah. So it has a lot of popular libraries which provides many functionalities to support CLI application and development. And it is also since it is pretty lightweight and fast, it is also used similar to C, like in the embedded programming space also, for on like low power usage embedded hardwares. And also network applications are also being developed on Rust. So that's also another popular space. And OS development, yeah, so obviously, like since C is capable of doing that, and since Rust is low level, it also supports OS development, since yeah, it's pretty bare metal and doesn't need any other bootstrapping for running it, right? So yeah, so there are some open source OSs like Redox or something like that. Yeah, so one library is there, like OS is there, which is open source, and yeah, you guys can see it if you search. Yeah, so it's pretty good for these all features, and also for web development itself, like uh, it's pretty good. Like there is one standard called WASM. Like it is a bytecode format. Like WASM stands for WebAssembly. So it is a format which we can run in our browsers. Like our browsers can run this parallelly to our JavaScript. So how we can use Rust with WASM is like we can write our code in Rust and we can compile our Rust code to WASM, and those WASM files can be loaded in the browser, and they can interact with the JavaScript, and yeah, we can do high performance code in this WASM environment, and the JavaScript can make use of this. Also, like it is very advantageous for like if there are any existing libraries or code which are already developed for other platforms. So like in Rust, so we can like just compile them to WASM, like retarget to WASM, and we can use them in the browser. So that is another very big advantage. Like the reusability of the code would also be increased. Like we don't need to write specific application for the browser specifically. Yeah. And yeah, blockchain. So in the blockchain space also, like Rust is becoming very popular. Yeah, so that is for the use cases. Yeah, so it will be useful for many space. Yeah, almost everything. So it is popularly used by AWS. So AWS has one micro VM named Firecracker. So it is used for like in the AWS Lambda and all. So our Lambda functions and all mostly run on like this VM which is written in Rest. So as a backend, yeah. So and Google's that new OS, this is also having some part written in Rest. And Microsoft is also investing a lot of on Rust language and for their OS level issues and all. So Microsoft had some research or like survey done where they found that more than 70% of bugs that they had in the past was mostly due to memory safety bugs, which could have been prevented if we have written in the Rust, like if we have written in Rust, unlike writing it in C or C++. So yeah, so Rust is very advantageous for preventing any security issue or like yeah those bugs mostly. Yeah. And yeah, so npm also, the npm infrastructure is also using Rust a lot. And Mozilla itself, like the Firefox browser had introduced many changes related to Rust. Like they had rewritten like their CSS parser and all in Rust, which gave them much better performance. Also, something which I didn't mention, like our Linux kernel is also recently like trying to introduce Rust to them as their secondary language apart from C. So that's also under main advantage, which will be having like yeah, which will keep Rust as a relevant language in the future also for coming much more time. So yeah, so like I have some references. So I think we have that in the chat also. We have pasted in the chat. So Siddharth, if you can paste it in the chat, if it's not available, you can do that. Yeah, okay. Yeah, so now we can go to like the basic REST constructs. So I'll just go through some basics as an introduction. So yeah, so we have this REST by example site, which is under the like REST lang website itself. So this has many examples, like hands-on examples, like from basics to like more advanced stuff, and yeah, all the features of REST. So this is one popular site. So I'll be giving the demo, like introduction through this about the language. And yeah, so as an apart from that, I'll just go through some relevant sites would be useful for someone who is starting to learn REST. So this is their weekly newsletter. So this is community driven, and like you can register your email and you'll get a good newsletter per week. So which is, it will have a lot of details, like including latest blog post to like what all Rust jobs are available. So those all things will be available in this. Yeah, so it's pretty good. And yeah, this is the Rust main website. So here they have a list of popular books and videos and like different contribution documents and all those stuff. Yeah, what all things can be built with Rust, like command line tools. Like here also they emphasizing on WebAssembly mostly, because it's really useful, and embedded and network, yeah, all this stuff. And for installation, basically you guys can just visit this page, and from the installation we'll get one rest up script. So we just need to run it for Linux subsystem or Linux Windows. We just need to copy this and run it in the terminal. So it will set up all the tool chain required, like a rest up cargo and the Rust C compiler and all those stuff. So yeah, that are the main things. And yeah, so there is another main book. So whoever is starting with Rust, like this is their book itself. So as an introduction, this book is also like giving pretty good explanation of all the features which Rust has. So yeah, it's some not that much long, but yeah, it gives different use cases, and like all the edge cases they talk about many things, like what are the advantages and drawbacks and all those stuff. So anyone who is starting with Rust, they can start with this book. So this will be very helpful. Yeah, and so as a community, like in Reddit, there is a subreddit for Rust, so which is also having like all the latest articles and what all things are happening. Yeah, so those are some common stuff. Yeah, so this is the like documentation page. So here we have the details about Rust standard library. So here we'll get all the details about like different libraries, what all modules we have in Rust, and like the description and their features. All this stuff will be available here. Yeah. So whenever we are developing anything, if we have any doubt regarding standard library, so this will be very helpful. We can just search here, like some file and all, like some modules. So we'll get all the details regarding that. So they'll be also having examples. So suppose for file, if we are considering this, we'll be getting an example also how to use the basic one for creating a file or something like that. Yeah. So this will be also helpful. So we can go to start with the Rust by example. Yeah. So here we'll be starting with basic hello world. So hope the font size and everything is fine. So, yeah. So like in Rust, like similar to C or C++, we have a main function. So this is how we create the functions. Like we have one fn keyword, and like we have the main function. So this is the starting point for the program. So, and this is the basic hello world program in Rust. So if we print this, run this, yeah. Yeah, so it will just print hello world. So like similar to C or C++, like in C we have printf for printing, right? So similar to that, here we have one println macro. So anything with this exclamation is a macro. So these macros we can use for printing to the console. Yeah, so we are passing the data and we can run with this and it will just print to the console. So that's the basic rest. Like we just need these constructs and all the logic goes inside this. So similar to GC, like where we have GCC or LVM, right? So LLVM. So we can, this is the compiler for Rust, Rust C. So we can pass the source file and pass it to this particular command. So it will compile it, and we'll get one dot slash. We'll get one hello, or like based upon what the file name, we'll get one executable, and we can run it like this and dot slash that executable. Yeah, we'll get the output. So common stuff. Yeah, so that's what the basics, like hello world. And so if you go to the next section, like comments, so this is also a common, like we have a double forward slash for commenting a single line. For multi-line we have this, which is similar to C or C++ itself. And for documentation we can have triple, and similar to that. So that's pretty straightforward. So format string, so as I told, like this print ln is a macro defined in the standard format library. So this is the standard library. So we have multiple such macros for printing to different locations, like standard, error, and different locations. So also we have this format one. So we can use this format macro for formatting a string. So if we want to format a string, like add a extra parameter and assign it to a variable, we can use this format string. So that's the main use. So this is similar to how println would be printing to the standard output. Format this can be used to write to a text as to a string type or some similar types. So we have some examples in here. Maybe let me see. Yeah. So if you see this, so the syntax would be something like this. So we can assign this format to a variable. So this will be replaced here. So similarly, we have some properties like we can print something in hex format or like octal format by adding, appending, or depending this 0x0o. Yeah. So that's for the basics. So we can now check the primitive types. So I'll be skipping through fast because it's we have some, like I won't be going through all of this, but I'll be selecting some main ones, and since we also have the demo, hopefully that also goes well. So as a basic primitive types, scalar types, we have like I8. So this will be like signed 8-bit integer, and like similarly we have 16-bit, 32-bit, 64, and 128, and this I size will be based upon the architecture type. It will have the respective size. And similarly, we have unsigned integers and floating point like F32, F64. Similar to how we have int or float in C or C++, we have we represent using this F32, 64 for 32-bit and 64. So and for single characters, we have char type. So it is 4 byte each. So that's it. And Boolean as usual. We have Boolean for storing true and false. And we also have one empty type. So this is an empty tuple which we have, which is similar to void. Like if we are returning in a void, so we mostly use this format. So it's similar to void. So if we are not returning anything, we can use this from the function or something. So so this is the basic format how we assign variables. So variables can be type annotated. Like we have one variable named logical. We have this let keyword. Whenever we are creating a new variable, we use this format. Let that variable name, and we have option for like having the variable type. and like we can assign its value. Similarly, if we want a float, we can assign it like this. And also we can have this regular annotation and suffix also. So if we don't specify the type here, we can add this value 5 and its type as I32 here, so as a suffix. So the REST compiler will know that it is of a I32 integer, signed integer 32 type. And similarly for float also, even if we don't pass it, the compiler will infer and it will know what the type is. Similarly for integer also. And if you see, so these are the default types which the compiler will assume. And if you see, this is another interesting way the REST compiler will know what the variable type is. Like if we assign it as an integer, so if we are thinking of this case, it should be inferred as an integer, right? So the REST code, like compiler will be checking the context also. So whether it is being like changed in the future, like in the code. So it can see that like it is having this type in the future. So based upon that knowledge, it will initially set this to I64 itself. So from the context itself. So by default, like when we define a variable in REST, we can't modify them. So or we can't mutate them. So like if we set value 1 to this particular variable, we can't change it to 2. So if we need to do that, we need to add one mute keyword. So it means that this variable is defined as mutable so that it can be changed in the future. So unlike other languages like C or C++, where by default all the variables would be mutable, right? And we add some constructs like constant to make them constant, right? So we have this mutable keyword. So we need to add this explicitly if we need to update the variables in the future. So this is one of the most important things in the REST language, which is mostly required. What do you say? Like for making REST language more memory safe and all its features. So we have this mute keyword, which is mostly used for our memory safety and for making giving that features in REST. So this is mainly useful. Yeah. So if you see, like if we set this to 12 and we can override it as the 21, and it's possible. Yeah, so if we try to override it with a true, like its type is changing, right? We can't do that because it's statically typed and we can't change the type of a variable already created. So but we can override it using the let statement. So this is like this mute variable had the scope till here. So after this, when we are accessing mute, since we created with let mute to true, so now it will be of bool type. Like we are not modifying, we are defining the variable. So it will be like shadow. Will be mentioned like it will be shadowing or overriding this variable. So whenever after this we use mutable, it will be always Boolean type, not this type. Yeah. So we have other common types like static array, fixed size array. So we can define the array in this format in REST. So this is the variable name, and for the array, this is an array of I32 integer 32 of size 5, and we can input its data like this. And we can also have this format which will initialize all the 50 data, like 50 locations with 0. So this is a way to initialize all the values. Yeah. So similar to how we have in C and C++, we can index the variables like array from 0. So this will print like first element of the array, and the value will be printed here at this location. Okay, so we can check some custom types which we have in REST. So some of the custom types are like mainly unlike C++, we have like unlike C++ where we have classes, we have structs here. Like structure, they are structures, so they have their own key like fields. Like here, this is a structure of name person, which has one name field and it has the type of string, and another one is age, which will be unsigned 8-bit integer. So these are some attributes like which we add. So yeah, so this attribute make this whole like person struct debuggable or like printable. So that's what we use this debug one. So these are somewhat complex concepts how we create these and all those stuff. So yeah, we don't need to focus on that as of now. So this is a symbol struct, and it can be of unistruct also, where we won't have any like fields, just the name, and we can have it as a pair. So it is a named tuple. So it will be having two values, but it won't have any names. And yeah, so similarly, this is example of struct with two fields, and we can have struct have another subtypes which is referring to another struct. So it is like this rectangle has top left as a point which is another struct, like this. Okay. So and when we are creating struct, like yeah, so this is an example. So here we are using this string type. So this is a like type which we get from the standard library. So it has this from function where we can pass the string, and it will create this string type. So this will be of the string type which we have defined here, and the age will have the unsigned integer. And after creating these two variables like this, we can assign them to this. So if we see, we can try to compile this. Yeah, this is pretty big. Let's see. So we have this Rust playground. This is one site which we can use for compiling Rust online. So if we write some code, we can check it online itself. It's online compiler. Okay, so let's try running this. Yeah, so if you see, so this created a string and its value, and since we have this debug like attribute, we are able to print the struct as a whole. So it will show that this is a struct of person type. I'll zoom in if it's not visible. Yeah, so it will be printing that struct as a name and age. Yeah, it's field. So similarly, we can get other values also, like if we add name. Yeah, so this is having some issue. So yeah, so we can get the fields like that. We can use this Rust playground for that. So if you see, so if here you can see this example, bottom right is a struct of this point type, and we are accessing it like this with .x. So we can use that for printing the inner values of a struct. So I'll quickly move to the next custom type, which is enum. So enum is like a particular keyword. Like we create an enum like this enum keyword and the name of the enum. Like we can add different values for this. So it can be a page load, these two common value unit like values which doesn't have any internal fields, or we can have a tuple like struct inside this, which will be like it is like having a character inside this, or we can have another one which having a string type inside this. So it will be mostly useful, like enum would be mostly useful like if we have if we want a common type, and it can behave in different ways different times. So like suppose we have this web event, and like the event could be any of this, right? So based upon that, like yeah, we'll be talking about this construct afterwards. So as of now, I'll just tell you guys. So if it can be of any of these type, right? So if it is of any of these type, like these two have any doesn't have any extra fields, but this has one character value field, right? So we can get that particular character and yeah, just print it or do have any logic based upon that. So similarly, if for page we have one string, so we can use that for printing the string or like for any other purposes. And yeah, for click, so this in value has like two fields, like the point fields, axes. So we can get those two values also. So if we need some common type, but inside that it with different fields with different behaviors, we can use enum. So this is one of the most useful stuff with Rust. Like we can have multiple behaviors for different enums. Yeah, so that's for enum. And yeah, so we can just go through constants also. So constants, like basically we have the const keyword and static. So these are mainly useful for creating global variables. So here we are creating this static and language variable with the value rest. So this is a static string, and this is const. So if you see, like the const and is an unchangeable value, so we can't change const, but static, whatever we define as static, as possibly mutable variable with static lifetime. So like there is another concept called unsafe in Rust, so we won't be going into that also. So like if we are using this unsafe thing, like it is like it won't follow like strict compilation procedure. So it's obviously like literally unsafe. Like it's up to us. Like the compiler won't guarantee us any of its checks, like most of its checks. So it will exclude many of its checks, and it's up to us to write safe code inside the unsafe block. So yeah, so whenever we need to modify any static like variable, global variable, we should have it as unsafe, or else it won't be doable because of the like constraints which Rust put up. So yeah, so these are some basic types. Hope you guys understood something. Uh, so we can now check the like variable binding, how it happens. Yeah, so like as we discussed, like we can have different types, and we also seen in the previous example, like we can copy like and assign variables to other variables also. Like if you see here, we are assigning this an integer, this particular integer value to this copied integer, and we would be able to use it in different cases, right? Yeah. So yeah, so the main thing is like uh, the Rust provides type safety using this static typing. So we always need to mention the type, and like or the it should be following a proper way, like proper combination. So that's the main thing with Rust. Like initially, when someone who is looking into this might be feeling like it is somewhat difficult by seeing this. So yeah, so once you are like familiar with this, like by writing more code or like watching some videos and like yeah, implementing some stuff yourself, so it will be much easier. So initially, it might feel somewhat hard. Like Rust has some learning curve, so that's one thing. Yeah. So. mm So this what here it is mentioning is like whenever we are defining any variable and we are not using it, the compiler will throw a warning, right? Like this is not used anywhere, and we should prepend one underscore to mention that it is not used to the compiler. So that's one thing. Okay. So that's basically the variable binding part. So next we can check the mutability. So as I told, like this mutability is and the main like concept in Rust. So if you see here, this is one variable which we define like underscore mutable binding, and another one mutable binding which we have the mute keyword, right? So if you see, like if you are printing this, this will print. Like we can maybe I'll show you in the playground. Yeah, so here the issue is like we have this particular variable which is not mutable, but we have this variable which we are initially assigning 1. So we are printing it like this. It will be printing this statement. And after that, we are modifying this. Since it's mutable, we'll be able to modify it. And after that, we are just printing that. And after that, we are just modifying the unmutable variable. So that's why we are getting this error at compile time itself. It will tell that as assignment to this and consider making this. Yeah. So it's the compile also gives some feedbacks to the user, the programmer. It suggests like if we do this change, it will fix that issue, or we can remove it. Because since it's not mutable and we are updating, we are getting this error. So if we remove this, we'll be seeing like the other one will be printing since it will compile. So the compiler would be able to find this issue at the compile time itself. Okay. So if you see, it is getting mutated, like it's adding one value, but since this is not mutable, we won't be able to update it. So the compiler has strict checking at the compile time itself. So which prevents many of the like memory issues which usually we have in C and C++. Yeah. So that's for mutability. Now it is regarding the scoping, like how we define scope in Rust. So this is like pretty straightforward. Like we might be familiar with this from some other languages also. So in here we can see we are defining one variable initially, and this is like we have another sub scope, like we have sub block or similar to our namespaces or something like that. So where we are defining another variable like short-lived binding with the value of this, and we'll be printing this here. So how the scoping work is like once we define one variable inside a particular block like this in the curly braces, and once we go out of that particular variable which was defined in that won't be existing outside the particular scope. It won't be accessible outside from that. If you see, like if we define this and print this, but it would be removed once it is out of this. So we won't be able to access this outside this. And if we print this, we'll be getting this error that it doesn't exist in the scope. And if we comment this out, then only it will compile. And if we print the particular our one which we have in the scope, it will print similar to this in so like this code. So whatever we have in inner scope, we won't be able to take it in the outside scope or use it in the outside scope. The compiler will give the error at compile time itself. Yeah, so we also have this variable shadowing. So it is like similar to that overwriting which we saw previously. So it is like we have this variable with value 1, and we can print it inside this. And after that, we are creating another variable with the same name, but this will override this particular variable inside this code. And once we print it, it will have different values. So this I can show you. So if we compile this, so if you see in this block we are printing this value 1, and the inner block we have this string. So we are printing this, and when we got outside, it is again printing the previous value which we have from this scope. So inside this scope, even if we override it, once it goes outside this scope, it will be going to the previous value, and we can override it again in this scope. So it will be now having the value 2. Yeah. So that's the basic stuff. Yeah, I won't be going to other details. Like every section has many field types and sections, so I won't be going to everything. Yeah, so I won't be going to this type part and conversion. Yeah, and I expression. Yeah, so this is also similar to what we have seen previously. So we have some common types of expressions are like we have this expression like variable binding and like common semicolon expressions. So if we have this main function, we can see this is our variable as assignment, like variable binding expressions. And we can have also format like this, where we can create a scope and it can have different values inside that scope, and we can use this particular expression. So what this will do is like this will calculate this value here and use those particular value as a assignment value to this variable y. So this is simply like if we are considering this as a function, inside a function we might have some local variables or something, and we can have some values inside that, and we can return it. So if we specify anything without a semicolon, it is like we are returning from that particular scope. So from this scope, we are returning the combination of this logic. So it will be assigned to this value. Yeah, and if you see this here, we are not having the semicolon. So the value which we here have, it won't be returned to this. So it will be null, or that unit type. So we can see it here itself. If you see, we have x here. So if we are printing x, so it will be having the initial value, and we are printing y. So y is having the logic, this subscope where we are calculating everything, and after calculation it will assign it to this value. And when we print it, it will print that particular value which is it got as a return from this type. And similarly for z, since we don't have any return type, as a void it will print this, our unit type or the empty tuple. Yeah, so these are the basics. And now we can go to the control flow. So we have our common control flow, like if else cases, conditional cases. So similar to like we can assign a variable with let n equal to 5, and we can check like n less than 0, and if it is, we can print, and else if we can check other case, and yeah, else case similar to this. We can combine multiple conditions using ampersand, and yeah. So this is pretty straightforward, like it's common in other languages also. And the loop, we have one infinite loop. So this is similar to while true. So this is like this will continuously run until we throw or like break inside some particular conditions. So this break and continue is similar to how we have in other languages. So it will skip all the continue, will skip all the rest and go to the starting, and break will exit out of this particular loop. So yeah, so that's also straightforward. And while loop is also similar. So this is pretty similar to the syntax which we have in C or C++. So while is also similar, like we have the condition, and based upon that it will continue the body, and once that is false it will go out. And we have some yeah, so similar to what we have in Python or something, what like for I in particular list. So this is like an range we are mentioning. So it will be like resolving to 1 to 100. So this value will iterate over these list, like this range. So based upon that, we can have that n value, and yeah, calculate or do our logic. So similarly, we have other different formats also. So to have yeah, proper like inclusive or exclusive, all those stuff. Yeah, so this is straightforward, and yeah, so I won't go to other details. You guys can refer this and yeah, Rust book for that. And we have another main thing is like match statement or match keyword. So this is similar to our switch cases. So we can see like we have a variable with value 13, and it is similar to switch where we give the value and we can check different cases. So here we are checking it whether it is matching 1. If it is matching 1, we'll print this, and if it is matching 2 or it is 3 or it is 5, like based upon this condition we can print this. So this is a pretty very like helpful stuff. So if this is like we also have this range. So if it is of in this range, it will print this. Yeah, and this underscore, it is like all other cases. So our default, it is like default case. So it will match everything else. So everything else will be printing this. Yeah. So for if you check the case of Boolean, it will be like match Boolean. If it is false, it will print 0, and true, it will print 1. Yeah, so it is pretty similar to switch cases, and it is pretty helpful. Like we can have these combinations and all this stuff to match the variable. So this is pretty helpful. And now I will go to functions. So how we have function Rust. So similar to our C or those languages, we can have a global functions like this. So like in C or C++, we have some like restriction on the order of function definition. Like we might require to define the particular function which we are using in our function or main function before the main function, so that or we need to mention the prototype before that, like that. So here you can see the function is defined below, and we are calling it from the main function here. So we are passing one argument, and it will return like do all the logic and print accordingly. So it is pretty straightforward. So the function prototype is like we have the function fn keyword and the function name and the type arguments which we take, like function name, like argument name and its type separated by colon, and the return type would be mentioned like this. So this is similar to return void. So this is equivalent to void as we discussed. So it is like this particular like symbol we use for like telling that it will be returning this particular type. Yeah. So if it doesn't have anything, it will be considered like it is not returning anything. Or if we can mention this also, if both are similar. Yeah. So when a function returns this unit type, we can omit it from the signature. So it's not required. So this is basic functions. So, and we have methods similar to how we have methods for some classes in C++ or something. Like we can create one structure, and we have this impl keyword. So we can use this impl keyword to implement some methods on top of this particular function. So if you see like all point associate function method going there. So all the methods or functions for this particular struct, point struct, will be inside this impl point block. So here we can define this origin method and new method or something, right? So for new, it will be like for creating the struct itself. So we can take the value like 2 points as an argument here, and it will just return the structure. So, and yeah, similarly, we can have the methods. This is a method, and this is a associated function. So associated functions are like it won't have the current object like this value of the particular struct, right? So it won't be able to refer the current struct. So here, if you see, it takes one self parameter initially. So this is this function would be of this format, like it is the variable self with the type self with capital S. So this self would be referring to this particular struct on which we are implementing. So, and if it is like we can call this particular return method like rectangle method like, let's see. Yeah. So we have this point structure, right? Initially, if we have this point structure, we have this particular new function. So for creating a new function, a new value, we can call this like this, like point and this double colon for scope resolution, or like for getting that particular function inside this particular scope of this particular struct, and we can pass it value. So it will create a type a point structure like this. And if we have this ampersand self, so it will be this function can be called using dot. So if you see here, we are calling the particular perimeter and area function using dot. So it is not, it will be, this will be having the data of this rectangle. So if we created this rectangle structure here, and we are calling, when we are calling this with this parameter, inside this perimeter function, it will be able to access the current struct and its internal data. And based upon that, yeah, we are able to assign its value to internal data, and we can do any logic and all. Yeah. So that's basic functions in REST. And I think we are running out of time mostly, so I'll try to skip fast. So it has basic visibility, like we can define a function as a public, and if we don't define this pub keyword, it will be meant as private itself. So it won't be able to access it outside one library or module. So we have this mode concept. So this is used for like creating a module. So this is similar to our namespaces in C++, C or C++, where we can create this mode, and inside this we can create some functions, and we can maybe create some sub modules also. if you see, we have this public module nested. So this is a sub module, and inside that we can have again functions. So if you see the usage, it is like we can access the global functions directly, and anything inside the module need to be mentioned like module name colon colon that function. If it is nested, again we'll have to mention this sub module and like that. Yeah. So REST has the concept of crates. So in REST, we like refer the libraries as crates. So in REST, the libraries are called as crates. So if we are creating a library using the REST C compiler, this is the way we can like do the crate type. So usually we don't use the REST C directly. We mostly use the cargo package manager for this purpose. So we can check that. So cargo is the package manager. So we can start a new project like when we are starting a new project, we can create a binary like this: cargo new foo, or like cargo new the library name. So this will create a particular folder structure. It like after the above command, you should see a file hierarchy. So if you are running it in the terminal, it will create a foo folder with this cargo toml. So this is similar to our package.json in JavaScript. It's the package file, and source file will have the source file. So this is the basic structure of REST, like the folder structure. And in the inside this cargo.toml, we have this package section and dependencies. Inside the package, it will have the basic package name, version, who is the author is, and the dependency section we can add the dependencies. So this will directly take from the crate.io. So that is the online repository. So we'll be getting the data from there, and we'll be getting the library from there by default if we don't mention anything. And we can also get a library directly from some GitHub repo. So we can use this for getting the Git repo data itself directly. So from that we'll get the library, or we can also use like the relative path for like modules which we have in our system itself. So using this, we can do the relative path, and using this remote GitHub one, and using this we can have our like directly from the crate. So those are the basics. So I will maybe quickly try to go to the demo for the Typesense part. So let me see. So like we have that the main objective we have with the Typesense project is like the Typesense already have many clients written in many languages. So by default, the Typesense like have provided API to their implementation, which we can use like our HTTP some clients like curl or something to do the request. So it will be like I can show you guys. So if you see, so if we go to the Typesense documentation page, we can see like different APIs which we have. So we have this API for creating a collection. So this is the API which we can use for creating a collection. So we need to so I have a terminal. Let me see. So if we so this is how we are doing the request manually using the HTTP. So here we are using the curl library for doing the request, where we are hitting like I have one Typesense server already running on my system using Docker. So which is pretty straightforward from their GitHub repo. We will get that. So here we are creating calling this collections endpoint with the headers, this X Typesense key. So this is for the API key, which is required for calling the API. And we are sending one JSON data. So this is the data which we are sending. So this is the name of the collection and its field, like what all field it has the company name field, number of employees and country, and it has their types also. And it has some default sorting field also. So this is how we call the our project using the HTTP clients. So if we are trying to use these clients directly in REST, like the issue would be like we'll have to manually implement like these endpoint, like logic to call these endpoints. Like we'll have to create the functions and use some HTTP clients, like libraries. Like if we are considering a Python or something, we can use the request library to do the request, and like we'll have to pass the uh, like header and all these details, and it will be like starting from scratch. Like it will take a lot of time. So all the language, if we have any project, we should have some interface or library in different languages to interact with our, like here in this case, our Typesense project, right? So that's the purpose of client libraries. So the client libraries will provide some interfaces, or like similar to functions, which we can call directly to like insert data or call this API underneath. So that logic that we saw here, like where we are sending this company and field name and all. So we in our REST specific implementation for the Typesense client, this would be the particular logic. So like we don't need to look anything else. Like I'm just, maybe if we have time, we'll show the live demo, but or else I'll just explain the code. So it is like we have one client which we initially create like this. Like, so we have the host name. So host name would be this part, right? And we have the a key, so that would be in the header. So in Rust, we have created this particular client builder, this function, which is internally using this hyper HTTP client like library. So internally, our client is using this particular HTTP library. We aren't implementing any HTTP library from scratch. So we are using this, and here we are passing the host name. So we are setting the host name API key, and we are calling some function build. So when we call this function like this, so here we are calling this associate function of this particular builder, and we have the member functions for this particular type, and we are setting the values. So internally, this client or instance would have all these values already set, and we have one interface called collections. So it will be setting this endpoint, like it is like hitting this collections endpoint, and underneath that we have create. So this create, what the create API will do is it will send one post request. So since creation would be post request, the create function would internally set post request, and here we are setting the type as by the company. So the logic what we have in the code is like we have one structure which we have created. So it has this field, company name, number of employees, country, similar to how we have here, right? So we have some logic going on here, like some attributes which will automatically modify this to have all the properties required to be sent like this. So we need it to be sent like having a type field, right? And the facet field, some, yeah, this is something specific to Typesense. So we need it to be sent in this format, right? So we have this document trait. So like document attribute. So we haven't discussed one concept named trait. So it is similar to like interfaces in Java. So we can create a trait, and it can have multiple functions. And if we implement that trait on a structure, it will be like if we are compiling and if we implemented that trait on a structure, it is important that that structure should have implemented those methods which are there in the trait. So if we see, maybe I can show you one example. Uh, yeah, so if you see, yeah, so don't have a trait as of now here. So this is the trait which we have. So we can create a trait like this. So trait, so and the trait name. So it can inherit from other traits also. So it must have these features like that. So this trait have one function. So any structure or any type which is implemented in this trait should have this type, this member function implemented for that. So it is similar to interfaces in like C# or Java. Yeah. So what we are doing here is, if you see, like, yeah, we are adding this document particular trait using this derive. So this will do some magic at compile time and create one implementation for that function for this particular structure. So those are like pretty advanced topics. So as of now, since we don't have much time, I won't be going to that also. So we have this structure company struct, and when we are calling the particular collection interface with this create, which will be creating the post request with this data. So once we call that, we'll be getting the response similar to this. Like, so in the response, we'll be getting details like created at what time it got created, and it will returning back all the fields we have already set, and also with some extra fields. This is specific to Typesense. So we create this like this, like create the library like this. So yeah, so this is the way how we create the collection from the API. We create using this, like from the terminal or something, or if we are using Postman or some other tool, we can static call and pass this value and pass the JSON body like this, and we create the collection. And if it is the code, like we'll have require some library, so that's why we created the client. So this client is pretty like currently in development phase. So yeah, so many things would change. So as of now, this collection, this function we have, so it will create this particular company collection, and it will return that particular data. And similarly, we have inside a collection we have documents. So collection is similar to tables in relational databases, and documents would be similar to rows. So inside a collection we can insert documents. So we have another example here, like we have this client and we have this collections function where we mention the company name, like which collection name, sorry. So which is company here. So here, if you see, we are having the collection name as company. So we are setting the collection name in this function, and after that, this is like we have this pretty functional syntax here. So after that, we have this document function which will return one document interface, which will have another create function, which will create a post request, and we can use this. Pass the document data in this field. So we are creating the structure, this particular structure. We are initializing its values, like ID will be giving empty as of now, and the company name we are passing country and its value. And once we create the variable like this, that particular struct, we can pass it into this create function, and we have this await like keyword. So this is for the asynchronous API calls. So this is our API implementation level stuff. So yeah, this is so because of it's synchronous, like we have implemented synchronous API, we need this particular field. So these are all pretty advanced topics. So like yeah, this will be how we call the particular API from the client, and in this we'll be getting the response. So what the response like we will be having in the database or the Typesense store. So if we are seeing like how we can retrieve the collections, so we have this company. We can try calling this from API. So I think Siddharth, I think we won't be able to run the code. I think we are already over time, right? Yeah, let me see. Maybe because there might be some debugging or some stuff involved. Yeah, so it might take some time. That's all. Okay. So another example would be like for getting the collections which we have created. Like we can call this endpoint like the collection and the company name, which is collection name, which is the companies right now, which we had initially sent, right? So if we call this, it will return that data, that particular collection which we have created. So if that return one value, right? So it's not pretty readable. So so we can create another collection. Uh, so we can just change its name, new, you can see. So you can see it's created under one, and if we try to fetch the call this endpoint, which will fetch that particular collection, it will fetch that also. And if we call the collections part only, it will return all the data. So the return value is like, I will paste it in. So to make it readable, yeah. So if you see, we call that API and we got two collections. So first one is the new companies and the companies. We got the two of them. So similarly, we have in the Typesense, we have APIs for deleting the collections. It's like we can call this delete API with the delete method. So it will delete the first one, and if you pass the next collection name, it will delete that also. And if we try to fetch all the collections again, it will show null. So as of now in the code, like in the client, we only have the collection creation one, and I'm currently working on the document API where we can insert the document and other stuff. Yeah, so maybe I'll show you guys, like it will give some error, but yeah, let's see. So we have this main function. So since this is that asynchronous function, we need some other keywords also to be added. So apart from that it is our basic main function, and inside that we are just calling our this particular function which we have created here, and we also need a wait because this is also that asynchronous function. So this will internally call our client. So let's see if it is built. So we can use cargo build. Yeah, so let's wait for some more time. So currently, like my system is pretty slow. Also, like this is currently checking for syntax and all, like not the compiler, but the our editor, the VS Code. So when you guys are developing something in Rust, you can use VS Code, and it has extension name Rust and Rust Analyzer. You can install this. So that will pretty much do the basic stuff for developing Rust. Yeah, yeah. If you see, like this is compiling. So it is compiling this particular project that we have. Let's see whether it will give any error or something. So our main logic, what we are doing here is like we are creating a client and we are just inserting the collection, which is having the name, this one, company is 22. So we can see once whether it is getting inserted, and we can use the curl library or something. So yeah, and one of the problem would be like, since the compilation has to check many stuff, so it might be slow. So that's one thing, because the compilation time might be longer because it need to check many stuff and like need to guarantee those stuff, right? Yeah. So the compilation finished. So this is a debug like compilation. So that's why it's not unoptimized, and like if you're running it would be pretty slow also. Like if you see the structure, if we compile, the folder structure would be like, we have our main project and we have source folder where we have our code, and inside the target folder we'll be having our executable. So similarly, you can see that we have the cargo toml file where we have the configuration, like the rest project name, the package name, and the dependency. So I have already added many dependencies. I have one local path to the Typesense client also. That's one thing. And in the debug folder, we'll be having our executable, like this learn rest.exe. So we don't need to, we can manually run that also. Like we can go to that folder and do that folder also, or else we can use cargo run. So cargo run will run that code directly. Yeah, so if you see, like, we have some other logic also after that. So at the compilation time, since we are not properly doing error handling or something, it is failing. So this is how the code will fail. Like, this is like runtime error, like our business logic error. So it is called like panicking. So in Rust we call it panic. So it is what happens when there is some compilation unhandled exception at the time of like running code. So we can see, like, we can check whether it got inserted. We can call our API again for that, getting the collections. Yeah, so if you see here, we inserted it using the client, and if you are using the curl library, we got it. We can get this response, where we can see that the name of the collection is company 20, companies 20. Yeah, so it is working. So we are still work in progress for this client, and your contribution is welcome. Yeah, I'm also first time contributor to Typesense. So yeah, so I'm currently working on the document API, and we have other guys also who are working on other APIs also. Whoever is interested, you guys can connect with us, or like, yeah. Yeah, so that's it for the small demo. Like, yeah, I couldn't do much, but yeah, I think, hope that would give you guys some idea about how stuff are working. And yeah,
Hey, Suhail, thank you so much for that. So Rust actually has a lot of a bit of a learning curve, and it's difficult for people to grasp it in a 1 hour session. For that, for sure. Then thank you for doing this. And like Suhail mentioned, Suhail and a couple of other folks are working on the Rust client as of now. If you're someone who wants to contribute, please feel free to get in touch with me or Suhail, and we'll be happy to have you over. Or if you feel you want to just shadow around and get a glimpse of how this is being built, and if you want to learn more about how client libraries are built and how Rust on the whole functions, please feel free to get in touch with Suhail or me, and we'll be happy to connect you with the project. Thank you so much, Suhail, for doing this again, and thank you so much for the audience for joining in and being a sport. We'll see you in the next week. Bye bye.
thank you guys.